Welcome to Books for Success. Today, we're delving into the wisdom within The Poetry and Music of Science by Tom McLeish. The Poetry and Music of Science, 2019, delves into the creative parallels between scientific inquiry and artistic expression. It explores how scientific pursuits, much like poetry and music, are deeply rooted in human creativity and storytelling, and how both domains are united in their quest to understand and interpret the world. Who's it for? Those wanting to know about the creative process behind discoveries. Artists, musicians, writers interested in the parallels between their work and scientific breakthroughs. Lifelong learners fascinated by topics like human creativity, innovation, and problem-solving. Before we begin, subscribe and ring the bell for notifications if you want to keep receiving the knowledge of book summaries about health, wealth, love, psychology, and much more. Don't be shy about dropping your book suggestions for us to summarize. Also, you can use this video as an audiobook summary. Let's grow and succeed together. What's in it for me? Discover the creative parallels between scientific inquiry and artistic expression. As you gaze up at the night sky, what do you feel? For many, it's a sense of wonder and curiosity, a longing to understand the mysteries of the universe. This is the adventurous call of science, to explore and imagine the unknown. Yet somehow science is seen as a rigid domain of facts and formulas, an arena that leaves no room for creativity, emotion, or the mysteries of human imagination. But the truth is that science and the arts are deeply intertwined in more ways than you might imagine. Pioneers like Albert Einstein, Marie Curie, and Isaac Newton brought paradigm-changing theories to life through storytelling, metaphor, and conceptual leaps of imagination or intuition. Their eureka moments were fueled by emotion and awe, not just rationality. Like composing a symphony or painting a masterpiece, they pursued truths that cannot be directly seen, only imagined. Failing to communicate the spirit of curiosity, wonder, and open-ended exploration at the core of science has had steep costs, too. It has discouraged bright young minds from seeing science as a creative adventure alive with mystery and imagination. Even more, it has hidden the common ground between science and the arts in ways that diminish both. This summary invites you to explore the magical intersections of science, poetry, and music. It reconnects science with the rhythms and equations, the poetry and cosmic mysteries, and the music that resonates among disciplines. It's a place where formulas sing in harmony, discoveries light a fire of euphoria, and equations unravel the hidden melodies of nature. A mysterious wellspring of creativity. The history of science is marked by many revolutionary innovations that came together in a moment, examples of long-contemplated mysteries that last revealed themselves with startling clarity in a flash of insight. Sometimes these eureka moments happened in the laboratory, and other times in front of a warm fire in a very comfortable chair. That's because, as Freud theorized, much of humanity's creative capacity lies below conscious thought, in the vast unconscious realm of the mind. In other words, human emotions and memories extend far beyond what the conscious self perceives. Neuroscience reveals many ingrained brain processes that enable our functioning, operating automatically outside of our conscious awareness. So, breakthrough insights often emerge unbidden, after a long period of incubation, when ideas are churning away below the surface of the conscious mind. And, like art, they rely on imagination, visualization, and synthesis to create new knowledge. Albert Einstein was a pioneer in understanding the role of imagination in discoveries. In one famous example, Einstein contemplates a man in free fall, accelerating through space with no forces acting on him. Based on established Newtonian physics, the man should perceive himself as motionless. But Einstein tried to imagine what the man himself would experience happening to him as he accelerated. This Gedanken experiment, or thought experiment, inspired Einstein's general theory of relativity. Gravity could not just be a force, as Newton claimed. Rather, gravity is the shape of space-time itself warping around mass, in this case, the man in free fall. Einstein imagined that if the man looked up, he would see the walls of space closing in on him. And if he held out a hand, his fingers would be drawn apart as the space around him stretched. Accelerating through warped spacetime would give the appearance of a gravitational force. This radical reconception of gravity emerged from the power of imagination. By picturing scenarios that challenged existing assumptions, Einstein's creativity revealed new facets of physical reality. These thought experiments, fueled by curiosity, shook the foundations of physics. Einstein showed that by speculating beyond the bounds of current knowledge, the scientific mind can glimpse previously unfathomed truths. The key is an open imagination, unconstrained by convention. Einstein also described combinatory play, the mind freely associating new possibilities. Solutions would arise suddenly without any effort, and without being able to give an account of them. Insights bubbled up from the unconscious after conscious work set the stage. In this way, Einstein demonstrated how scientific creativity draws from the same deep wellspring that nourishes the arts. The key is cultivating an open, curious mind, one ready to receive the gifts arising mysteriously from the unconscious realms within us. A fresh vision. Your eyes may take in visual information, but how you interpret what you see depends on your perception. Two people can look at the identical scene yet come away with completely different impressions. That's because perception is colored by experiences, assumptions, emotions, and imagination. What the eyes see is meaningful only in context, framed by an individual's particular lens on the world. So your beliefs shape what you notice and how you ascribe significance. The world presents an impression, and you recreate your own version through your imagination and perspective. For thousands of years, for instance, civilizations studied the night sky, seeking order among the stars. Complex models emerged, showing the sun, moon, and planets circulating in perfect spherical paths around the Earth. This comforting vision of neat celestial spheres became ingrained over centuries in religion, philosophy, and culture. But as telescope technology advanced, astronomers began noticing deviations that defied the established model. Rather than circular, planetary orbits appeared elliptical and blurred. This led Copernicus to propose a sun-centered solar system by the 16th century. Similarly, in the early 1900s, Vesto Slipher noticed through spectroscopy that some spiral nebulae exhibited red shifts, meaning they were rapidly moving farther out into space. Edwin Hubble confirmed Slipher's findings and interpreted the red shifts as evidence these nebulae were actually distant galaxies. Hubble realized the universe was expanding, defying the static model. What changed the actual cosmos, or our limited perceptual lens? This shift in perception, in turn, led to Einstein's subsequent realization that these puzzling observations called for a complete reimagining of cosmic space itself. To make sense of the data, he conceived his revolutionary theory of relativity, in which space and time form a dynamic spacetime fabric that can bend, stretch, and expand. Einstein showed that the universe was not static and enclosed, but constantly growing. This profound shift from classical astronomy's orderly spheres to a cosmological spacetime that has evolved over billions of years was difficult at first for scientists to visualize and accept. But Einstein's abstract models explained the empirical evidence in a new conceptual framework. As if in parallel, by the late 1800s, avant-garde painters were also challenging long-standing assumptions about visual representation. The Impressionists rebelled against strictly realist painting that attempted to reproduce precisely every detail of reality. Instead, they used rapid brushstrokes and unblended colors to convey the subjective experience of a scene in one fleeting moment. Artists like Claude Monet captured ephemeral effects like the warm glow of sunlight or cool hues of rain playing across a cathedral facade. Rather than painting the cathedral itself, he aimed to share the impression of changing light and mood throughout the day. This approach seemed shockingly abstract and unfinished to traditionalists. Like trailblazing scientists, pioneering artists periodically re-envision how to represent the world. Those with the creativity to question convention can reveal new facets of reality and understanding. The mathematics of music and the longing for order. Imagine you are Johannes Kepler, the 17th century astronomer, walking home under the glittering night sky. You hear a lutist practicing an intricate piece through an open window. The melodic patterns resonate in your mind, seeming to reflect cosmic harmonies you've observed in planetary orbits. In 1619, Kepler was moved to author a book called Harmonicus Mundi, meaning the harmony of the world, finding parallels between musical structures and the mathematical order seen in astronomy. Though planets followed elliptical rather than perfect circular paths, Kepler still discerned profound harmony in their motions. Centuries earlier, discoveries attributed to the ancient Greek philosopher and mathematician Pythagoras also hinted at deep connections between music and math. Pythagoras is credited with demonstrating how different musical tones were derived by dividing lengths of string into simple ratios of whole numbers. This demonstration of harmony through mathematical ratios would delight generations of philosophers and theorists to come. Today, mathematicians continue exploring dazzling fractal symmetries, some inspired by musical counterpoint and improvisation. Benoit Mandelbrot, pioneer of fractal geometry, was fascinated by the improvisations in jazz, which create spontaneous, recursive variations on a theme. Mathematician Dmitry Tymachko has analyzed the geometric structures of jazz chord progressions, finding deep parallels to orbital resonances in astrophysics. Stefan Alexander, a professor of physics and a jazz saxophonist, has written extensively on the connections among jazz improvisation, fractals, and the cosmic harmonic order. Like jazz musicians improvising together, mathematicians collaboratively riffing on abstract concepts experience exciting moments of spontaneous insight when new patterns emerge. As they recursively twist mathematical motifs into infinite variations, they find aesthetic delight in this endless play of symmetry, resonance, and imagination. Like music, higher mathematics entwines logic with beauty in a wordless but expressive and aesthetic language. Mathematical spaces far exceed physical applications and model the abstract. Music, too, conveys ineffable meanings beyond language. As mathematician Richard Current described, these disciplines resonate with humanity's contemplative reason and desire for order and beauty, revealing as much of humanity's desire for order, balance, and proportion in the universe around us as art itself. The emotion of science. What truly drives discovery? In the arts, it's easy to answer with words like passion, dedication to expression, and emotion. And for scientists, the very same is true. Passion-fueled pioneers like Marie Curie, Albert Einstein, and Werner Heisenberg as much as reason did. Marie Curie's thirst to understand radioactivity led her to isolate new elements like radium and polonium. She said her research required patience, perseverance, and passion to fuel her remarkable breakthroughs. But it also meant managing her fear. Though she was aware of radiation's mounting health risks, her sense of wonder compelled her to continue the groundbreaking work despite the dangers. Pioneer of atomic physics Niels Bohr struggled intensely to reconceive atomic structure using the nascent framework of quantum theory in the early 1920s. For months he agonized over how to understand perplexing new experiments like electron diffraction. The answer came suddenly in 1922 while he was hiking high in the Norwegian mountains. Bohr later described the experience as one of the biggest thrills of his life. In an instant, he envisioned electrons orbiting the nucleus in quantized orbits rather than fixed rings. This intuitive leap laid the foundation for his pioneering atomic model. Bohr emphasized that in addition to rigorous logic, transformative discoveries require passion, imagination, and an almost artistic intuition. His own revelation arrived only after months of immersion in the problem, when sudden inspiration struck during a moment of relaxation in nature. Bohr's deep insights enabled him to reimagine the atomic realm, blending empirical data with creative theorizing. His quantum model of the atom advanced physics for decades. Physicist Werner Heisenberg vividly described a similar moment of exhilaration in his breakthrough about quantum mechanics. After years struggling to make sense of perplexing data on atomic particles, he finally conceived a theoretical framework that fitted the evidence. That sleepless night, working feverishly with mathematics, Heisenberg felt he was unveiling nature's strange inner beauty. Entirely new vistas were unfolding before him. The sense of joy and aesthetic appreciation in those moments of insight remained with him years later when he reflected on the creative process. In other words, Heisenberg portrayed his eureka moment as intensely emotional with phrases like, strangely beautiful, conveying a sense of unlocking nature's mysterious inner workings. His account provides a first-hand glimpse into the passion and aesthetic sensibility that fuses with rigorous science during such groundbreaking discoveries. The most brilliant minds understand that humans are emotional, imaginative creatures as much as rational thinkers. Our passions, fears, and dreams shape discoveries. Science, like art, requires emotional as well as intellectual commitment to pursuing elusive cosmic truths. A shared path of discovery. The creative journey follows a similar trajectory, whether it's crafting a painting, a novel, or a scientific theory, and this underlying structure reveals yet more entwining of science and art. The path begins with an initial vision glimpsing an unseen possibility or goal, though its ultimate shape is unclear. Such flashes of insight spark an emotional desire to actualize the vision, providing the passion to persevere. Next comes a laborious phase of industry, actively working to give the vague impulse concrete form. An artist sketches, studies, mixes paints, arranges compositions. A scientist devises hypotheses, designs experiments, analyzes data. But this rigorous effort reveals the constraints that will focus the work. Early ideas may prove limited or flawed. Days pass without progress. Frustration and doubt may arise. The breakthrough arrives when a new pathway illuminates suddenly, often during incubation periods when the creative mind relaxes and wanders freely. The unconscious continues churning, making novel connections that eventually surface as illuminations. A composer might dream of a melodic motif. A chemist might envision a molecular model while stepping away from the lab bench and walking in nature. Illumination feels effortless, yet exhilarating. But raw inspiration alone is not enough. Rigorous verification ensures intuition aligns with the data and the constraints. Not all hunches prove valid when tested thoroughly. The euphoria of illumination must be balanced by the disciplined effort of verification. The creative pilgrimage coalesces when diligent work finally shapes the original impulse into an authentic outward form. The completed painting, composition, or theory both resonates with the initial vision and respects inherent limitations. The end result, or the arrival, often looks quite different from the preliminary glimpse that launched the journey. This general narrative arc recurs across artistic and scientific domains, though specifics differ. Both interweave the power of conscious rigor with unconscious creativity. Breakthroughs depend on actively cultivating vision and desire, embracing constraints as guides, not obstacles, allowing mental incubation, then rigorously verifying sudden illuminations. Together, these stages form the timeless creative path from inspiration to discovery. Final summary. Both you and visionaries like Einstein and Niels Bohr share the primal urge to comprehend the world through creativity. By blending rigor with intuition, they illuminated unseen realities, fueled by imagination and emotion. Science, like art, persists through desire, retreat, sudden insights from the unconscious, and the testing of new visions. Understanding this timeless arc reveals everyone's shared capacity to re-envision the universe. When you let science and art harmonize within, you rediscover profound wonder at life's mysteries. Thanks for being part of our insightful voyage. If our summary piqued your interest, we encourage you to dive into the complete book for a deeper understanding. Don't forget to like this video, subscribe for more content if you're new here, and share it with others who might find it valuable. Keep on reading, discovering, and advancing until our next adventure.